You learned during this module about the two measures that objectively evaluate the performance of experts within the classical model. That is, statistical accuracy and information score. The statistical accuracy, or calibration score, measures how well experts' uncertainty assessments correspond to the actual realizations. It results from performing a statistical test, which measures the degree to which experts' assessments capture the true values at the expected frequency. The score is the p-value of a statistical test, a typical output in the classical statistical setting. So, this beautifully connects with the classical statistical theory, which led to the birth name of the method. Nowadays, the method is also known as the Cook's method or even the Delft's method. Finally, bear in mind that the statistical accuracy is computed for all calibration questions and will take values between 0 and 1. Intuitively, the information score measures the degree to which a distribution is concentrated. It is determined for each question. We saw how determining the information score also requires us to associate a distribution for each question. The information is then measured with respect to a background measure, typically chosen to be the uniform distribution. The information score can take, in principle, any positive value, but typically is lower than 3. The two scores help us to answer the following question. What is a good probability assessor, subjective probability assessor? A good subjective probability assessor is statistically accurate or calibrated, which is reflected in a high calibration score. Also, a good subjective probability assessor is informative, which is reflected in a high information score. To see the two scores at work and how experts' performance can be objectively measured, let's consider some examples from a real study. We will admire now 3 vintage graphs. Later on, you will find out how to make the graphs yourself and also learn about more modern options. The first graph shows the assessments of an expert for 10 calibration questions. The 50 quantile is marked with a star. The confidence interval is determined by the 5% quantile on the left and the 95th quantile on the right. So the expert expresses the fact that he or she is 90% confident that the true value lies within the 90% confidence bounds. We then expect that in 90% of the cases, the expert will capture the true value within her or his confidence bounds. Now, for each question in our example, the true value, that is the realization, is marked by a hashtag. It is quite clear that our expectations are not met, since just one realization, that is for question 53, is captured within the bounds. This is reflected in the very low statistical accuracy, that is of 10 to the minus 7. The information score, however, is quite high, as reflected by the concentrated assessment. We can say that these assessments reflect overconfidence. All in all, the expert's assessments provide a high information and very poor statistical accuracy. We see now the assessments of a second expert. The assessments reveal quite high uncertainty given by the wide confidence bounds. The informativeness is therefore quite low, of 0.53. As a result, the expert manages to capture the realizations in all 10 questions. So the statistical accuracy is quite good, of 0.57. The last expert's assessments reflect quite high informativeness, of 1.77, along with a distant statistical accuracy. Overall, which expert do you think performed the best or the worst? Is this in line with what your opinion stated in the discussion? Do you maybe want to revise your choice? Thank you for your attention.